Welcome to the part 7 of this SwiMove course. In this lesson, we're going to talk about subscription payments. And here's our agenda. So firstly, we'll give you the project overview. Then we'll walk through the project design and specifically the subscription payments. Then we'll see the code example of the payment, which is a smart contract. And finally, we'll do some deployments and testing. So the blockchain technology has opened up some new potentials and solutions for traditional subscription services. Here are some of the features of the subscription services on blockchain. The first one is decentralization. Subscription services are implemented through the smart contract that do not require a central entity, increasing the trustworthiness through this decentralization. And the second one is automation. Transactions can even be automated with the smart contracts, which increase your efficiency and speed the process even further. And lastly, we have the instant traceability. Blockchain creates an audit trail that all the documents and the provenance of the asset at every step can be traceable. Let's look at some project overview. When talking about subscription services, it usually refers to a payment model where the user pays a fixed amount of money at certain intervals to enjoy a certain service or benefit. Subscription services are very common in the modern digital economy, and they are widely used in a variety of fields such as streaming media, music services, etc. Okay, let's see the project design of the subscription payments. So here we design the function and basic architecture of the subscription contract. The contract contains 4 functions, among which subscribe, close, extend are the user interface to creating, closing, and extending the subscription function, and withdraw is the function for the administrator to withdraw the subscription fee. Any operation of the user on the contract will trigger some events. For example, subscribe will trigger the subscribe create event, and these events will be monitored and captured by the program on-chain to give the user the services of subscribing members. We define a global share object global config here, which contains the administrator's address and subscribe store fields to store the subscribe ID. Each user's subscribe will have a corresponding unique subscribe ID, and through the ID stored in the subscribe store, while the ID is recorded in the output and in the input, and output by the user's address mapped to the vector of the table. We also define a subscribe here, which is used to store the information about the user's subscription and the coin used for the payments, which is recorded in the subscribe store with a unique ID containing start time and stop time, and an interval to control the linear payment of the subscription. The contract we design contains 4 APIs: subscribe, withdraw, extend, and close. The function of subscribe is to create a subscribe object, which contains the token that the user needs to pay, the payment start and end time, information, etc. The withdraw function allows the administrator to withdraw the tokens paid by the user from the subscription. And the extend function is for the user to pay the corresponding proportion of tokens if the user wants to extend the subscription service. Finally, the close function is for the user not to subscribe to the service, and they can cancel the service anytime. Next, we'll specifically implement our subscription contract. So firstly, we'll create a global config in the initialize function and initialize the subscribe ID to 1 as the ID of the next subscribe. Then we'll set the address of the admin as the address of the deployer, and finally create an empty table to store the subscribe object. So the subscribe function allows user to create a subscription services. The user needs to pass in the corresponding coin token, first compares to the current time with the start and end time to ensure that the time parameters are reasonable. and then obtain the next ID recorded in the global as the ID of the subscribe. Interval is now how many tokens the subscribed object can release at each time interval, and it needs to ensure that the time between the start and end time is an integer multiple of the interval. So, recipient can withdraw the coin from the subscribe via the withdraw function. And withdraw is used for the administrator to extract the release coin, mainly to verify the current time, and verify the address to ensure that it is the recipient address recorded in the subscribe. And then we'll call the withdraw inner function, which will handle the specific extraction logic. In the extend function, we need to ensure that the added coin is the same portion as before, and then update the end time and remaining amount of the subscribe object. Close function ensures that the user can cancel their subscription at any time if they no longer wish to subscribe to the service, and returning the remaining coins to the user. When the close function is executed, the withdraw function will be called first. This part has the same logic as the withdraw function. The return coin will be transferred to the receiver address, and then the subscribe object will be deconstructed, and the reverse will be returned to the sender address. Let's start with the deployment and testing. We'll use the test scenario to create a multi-transaction test environment to fully test the API of the subscription contract. And here, we'll create 3 subscribes in a transaction to test the withdraw, close, and extend function respectively. And set their time increments. We'll set the amount to 1000 and the interval to 10, which means that 100 coins will be released every 10 milliseconds come out. So the second transaction is initialized by the receiver address set in the subscribe. Use the subscribe with ID 1 to test the withdraw function. And we'll set the clock time to 40, 80, 100 respectively. Then the coins that the withdraw function can extract should be 400, 400, and 200. In the next transaction, we test the close function through the subscribe with ID 2. It start and end time at 100 to 200. We set the timestamp to 150. Then call the withdraw function, take out half of the coins, and then set the time to 170. The close function will return the remaining coins. According to the logic, 300 should be returned to the user, and 200 will still be paid to the receiver address. And initially, the start and end time are 200 and 300 in this transaction. But through the extend function with ID 3, we extend its stop time to 350. Then we check at time 330 that the withdraw coin is 1300 coins. And that completes the test of the extend function. So we'll use the swim test to test the unit test. And after that, if you see the console information like this, it means you have successfully executed the unit test. Next, we'll use the Swimmu build to compile the module in order to publish on-chain. And after that, we can just call the Sui client publish to publish our module. Then we'll create a subscription with an amount of 10 Sui coins using the following command. So as you can see here, we have the Sui client call, and the function is subscribe under the module subscribe with the package ID and also some arguments. So through the transaction, it can be found that the transaction consumes 10 Sui coins. And we'll modify the address in the configuration file of the Sui client so that the address of the sending the withdraw transaction is the recipient address in the subscription object. Then we'll use the following command to withdraw coin from the subscribe. And after we send a withdraw function using the recipient address, we'll successfully get 10 Sui coins. Okay, we'll have an exercise for you to get your hands dirty. So you'll try to complete the following exercise. Firstly, you'll code a subscription contract that includes the above APIs. Then you'll build and publish to the Sui network. After that, you'll call the relevant APIs to complete a complete service process. Then you'll listen to the subscription events through the SDK. And you can find our reference subscribe code by the MoveIt here. So that's it. That's the end of this course. And I hope to see you again. Bye bye.